All right, guess let's get started here today. Hopefully we'll have a few more people joining us in a bit. But let's start off with any questions that you've had that have come up on the homework that you want to kind of look at or work on together. Nothing? Everybody is feeling just awesome about what we've done so far? All right, make sure you remember to get that Module 5 quiz taken online, and remember you can do a retake for it also, right? I sent out an announcement yesterday that had a lot of important information in it also, so if you didn't see that, make sure you check your announcements and look for that. I did give some information about the final exam, and so were there any questions though that you have still about the final exam or anything in that announcement that you wanted to discuss? Nothing? Are you guys excited that you get to use notes on your test, on your final exam? Yeah? Okay, so that should be hopefully a bit of a stress reliever for you, I hope, because sometimes that can be kind of, crazy and stuff, but we don't usually do that, so you guys are lucky that way. You get to do that. So, let's see. All right, well, I think I covered everything in that announcement, so just make sure that you go through and read it carefully and reach out to me if you have some individual questions you want to talk about. Okay. All right, so 6.3 is where we are at today, and we are going to be talking about how to undo those exponential functions that we talked about last time. Okay, and so that is called logarithm. A logarithm is what we're going to be talking about today. I know it's kind of a weird word, okay, logarithm, but that basically just means that we're undoing exponentials. Right, so whenever there's a way to do something in math, there's always a way to undo it. And so that's what we're going to talk about today. How do we undo these exponential equations? Okay, and that is the logarithm. So first of all, I want to talk about how things are kind of related to each other when we have logarithms and exponentials. Because you're going to be asked to change something. So you're going to have exponential form, and you'll have logarithmic form. And it's going to ask you to kind of go back and forth between these two different forms, because sometimes one way is going to be a better way to try and solve an equation that we're doing, or maybe with graphing it's going to help us. So we've got to be able to know how to go back and forth from one form to another. So that's what I want to talk about first. So if something is in exponential form, it looks like this. It's in this form. So b to the x power, right, equals a. Right, so b, this is the base, right, and this is the x is our exponent, and whatever b to the x power is gives us some number. Right, but when we have it in logarithmic form, so I want you to notice the same a, b, and x are going to show up in this logarithmic form, and they're going to be represented by the same numbers. Okay, so in log form, you're going to have log base b, so it's kind of like a little subscript. It's a little b, it's not right next to it. Okay, log base b of a equals x. Okay, so again, like I said, that a, b, and x are the same a, b, and x that you see over here. Okay, and so we can go back and forth between these two different forms. Okay. All right, so let's practice first of all just changing from one form to another, because we got to get really good at that because we're going to be doing a lot of that for the remainder of the semester, because this is the last module, right? Can you believe it? We made it to the last module. Yay! All right, so let's try this. What if I have m to the third power equals 5? All right, so I can see what I have here, right? So m to the third power equals 5. So my m is the b in here, 3 is the x, and 5 is the a. So when I change this into logarithmic form, right, we're going to have a log in there, and you've probably seen that log button on your calculator. We're going to get to that in a little bit too, talk about that log button. All right, so log base b, so the base on this one is m. So remember, it's going to be kind of a little subscript there, right? Of a, which is our 5, equals 3. Right, so just changing it from one form to another. So remember, this is the base. Let me underline this here. This is the base of the exponent, and this is the base of the logarithm. Right, they're both the base, and so that's why they're both end up being that same number. And logarithms always, right, when you're finding the log of something, notice that this is the exponent when it's in exponent form. So what you're trying to find when you're taking the logarithm is what is the exponent on that. Okay, so this is, so logs, find the exponent. Okay, I just want to make sure that's clear. That's why that exponent is what this equals. All right, let's do just a couple more here. So let's try this one. So if I give you 2 to the third power equals 8, right? And that's a true statement. 2 times 2 times 2 is 8. But if we were to write it in log form, right, we would say log base 2, so it's a little 2 here, of 8 equals the exponent, which is 3 in this case. Right. So, let's see, maybe so if it gives you, this, in exponent form, our answer is going to be what it is in log form. Okay, what about, let's do one with a negative exponent. Talk a lot about the negative exponents when we did the properties of exponents, and those are going to come back into play here because, again, exponents and logs are related to each other. They just undo each other. All right, so what if we have 3 to the negative 4th power equals 1 over 81, right? And this is a true statement. If we flipped it, to the bottom and raised it to the 4th power, we'd get 81. So remember, negative exponents always give us a fraction there. Okay, but this is what's given to us. And then to change it to log form, all right, we'll do log base what? Base 3. All right, of what? What's going to go here?
Is it 1 over 81?
It is 1 over 81. And then what is that going to equal?
-4.
Yeah, that -4. All right, so when we take the log of something and we end up with a negative number, right? Remember, that's telling us that you know, when we raise it to that exponent, it was a fraction, right? So we expect to have that fraction here. All right, so all of these things are just like all interconnected together, and hopefully as we kind of go along in this chapter, you'll be making some of these connections together with our, you know, with the exponents and with the logs, especially with the things that we've already talked about with our exponents, okay? All right, let's do a few examples now going the other direction. So what if they give us log form and they want us to find the exponent form? Okay, so we have, so I'm going to write it over here so we can kind of keep it straight here. So what if it gives us log base 4 of 16 equals 2? Right, how would I change that to exponent form? So let's start off with, what's my base? What's the base of this? Remember, the base of the log is that little number there next to it, so it's going to be 4. All right, so we're thinking 4 to the what power? All right, and so that's going to be this 2 over here equals 16. And is that a true statement? Is 4 to the second power 16? Yeah. Okay, so we can kind of see that. And maybe if you're trying to think, for some reason it's a lot harder for students to go when they're given the log and then to come, you know, to get to this answer. So I sometimes tell my students, well, okay, always start with the base, right? So that little number there, and then you're going to raise it to the power, right? Whatever number's on the other side of the equal sign, and then it's always going to be equal to that big number, right? So it kind of does this little circle thing. Start with the base, raise it to this power, it's going to always equal that number. Okay? So just a way to maybe help you see how we're going to rewrite those. All right. What about this one? What if I have log base 10 of 100 equals 2? Oops, I meant to put that in the other place though, sorry. I'm going to kind of keep it straight so we have all of our logs on the same side. It'll just be a little easier. So let's do log base 10 of 100 equals 2. All right, so think about this little circle thing that I said. See if we can kind of get that answer there. Okay, what do you guys think? What is this going to look like? Where are we going to start? What number?
Start with the number 10.
Okay, yep, so 10 to the what power?
Second.
To the second power equals
100.
Yeah, and is that true? Yeah, that's a true statement, right? 10 times 10 is 100. 10 to the second power is 100. Okay. All right, let me write it down there, sorry. All right, so this is just switching back and forth, right? Just getting used to, you know, changing from one form to the other form, right? And just doing some practice with that will, you know, help you get that down a little bit better, okay?
So, what's the purpose of that?
Changing from forms to another? Well, we're going to kind of
explain the scientific notation and that it's used for big numbers. What would be the purpose of switching it to this?
So you're going to see it in the next example. So the next example, we're going to be asked to graph a log equation. But it's actually harder to graph it when it's in log form. And so what we're going to do is change it to exponent form, and that's going to make it a lot easier for us to graph. It also is helpful when we're solving them to be able to do it like that. But the whole thing that logs find for us, like I said up here a little bit earlier, is we're trying to figure out what number, right? What's the exponent? That's what we're always trying to find. Logs find the exponent. Because if we didn't have logs, and I want to kind of do, something with you here, we're going to try and, see a little bit of, of what we could kind of come up with. So I want you to try and figure out on your calculator, right? If you do 3 to the what power equals, let's have 127. So on this, that means you're trying to, figure out, so I want you to just kind of do some guess and check. So use your calculator, right? And you're thinking, okay, 3 to the what power, right, will give you that. And so you kind of have to play around a little bit there. But if I do 3 to the, if I do 3 to the one that we always seem to look at a lot is like 3 to the 4th power. And just kind of write a few things over here is 81, right? And if I said 3 to the 5th power, that's going to give us 243. So this 127, right, is somewhere between here, right? It's between 81 and 243. And so that means my exponent, right, that I'm finding here can't be a whole number answer. So when I'm trying to figure out what this is, so 3 to the what power gives me 127, I'm going to kind of keep going, okay, well, 3 to the 4 point something, something, something power, right, is going to get me close to 127. Right, so I want you to try that on your calculator. So maybe do 3 to the 4.1 power, 3 to the 4 point something power. And I want you to try and get as close to 127 as you could possibly get on that. And you might need to take it out 2 decimal places, or maybe you'll have to take it out 3 decimal places. Okay, so just kind of keep trying, just play around on your calculator. 3 to the what power is going to get you something close to 127. Okay, so Jordan said 3 to the 4.42 power. So everybody put that into your calculator and see what you come up with when you do 3 to the 4.42 power. Put that over here. So that's approximately 128.49, blah, 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 right? So I want you to get even closer than that. So you might need to take it, you know, out a little bit more, or, you know, what if you went down? What if you did 3 to the 4.41 power? Does that get you closer to 127? So if you do it just to the 4.41 power, then I get 127.088, blah, 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 right? So that's even a little bit closer, right? But if we wanted to get these 8s so that they were closer to 0, I could take it out maybe even one more decimal place. So 3 to the 4.41 what power, right? So take it a little bit more. Try and get as close as you can. We're going to have to go to the 0 point, or like 4.40 something, 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 right? I mean, this is pretty close, right? But as you take it out more decimal places, you're going to get more and more accurate. It's going to get closer and closer to that 127. So that's what we're trying to find when we're doing logarithms. We're trying to figure out what base, right? What exponent are we going to raise to the base that we're given that's going to give us something really close to that number, right? Does that make sense? What I'm saying? Does that make more sense, Jordan, what we're trying to find there? Or what?
Yeah.
Okay. So using logarithms, we can get there quicker, right? And we don't have to kind of do all this guess and check stuff like you'd have to if we didn't have logarithms. And I'll show you a little bit more with that later on today and what I mean by that. Okay, but let's look at some graphing of these logs. So last time we talked about graphing some exponential equations, but now we want to graph some log equations. And so we're going to kind of compare and contrast what they look like. So a little bit from last time, right? We said that if we had y equals 2 to the x power, that kind of looked like this, right? This is just a little rough sketch of it, but it looked something like this, right? And then when we had y to the 1/2, right, all raised to the x power, what happened with that one? You guys remember? How did our graph change on this?
It looks more like a negative slope.
Yeah. Right, so this is more positive, right? Because we called this was exponential growth. If it looks like this, because as you're looking at it from left to right, it's going up. But when we have a 1/2 there, then it's starting up high here and coming down and getting closer and closer to 0. And so we call this exponential decay. Right? And so right now, I mean, I know you guys hear a lot about the coronavirus and stuff like that, but it is kind of interesting understanding mathematically what is happening with it and understanding that, okay, so far we've been in this pattern of exponential growth, but we want to get into this pattern where it's actually coming down, right? And so the cases are getting closer and closer to 0. And so at some point, right, it's going to top off, and then we're going to have another exponential curve going down, right? And hopefully, as long as people are social distancing and stuff like that, we won't have it go down and then come back up and then go back down and come back up, right? So everybody's got to do their part so that we can get that down closer and closer to 0, right? And the only way to do that is to just not be in physical contact with a lot of people. All right, so these were exponential graphs, right? But today we're going to talk about graphing logs. Right, so let's see here. So let's do, so for example, example 6, I think. So I want you to graph y equals log base 2 of x. Okay. Now, usually we would pick x's, right? So we'd make a little xy chart here, and we'd pick x's and figure out what y is. But a lot of your calculators don't have a log in base 2. Most calculators just deal with base 10. And so for us to be able to graph this, right, if you don't have a base 2 on your calculator, then what we're going to do is we're going to change this to exponential form. So we can kind of see the relationship there, and then we can graph it from that form. Okay, so let's write that down here. So we're going to change, first thing you want to do is change to exponential form. Okay, and when we do that, right, let's do that here. So we're saying we're going to start with that base there, right? So we're saying 2 to whatever is on the other side of the equal sign. So 2 to the y power equals x. Okay. Is everybody okay right here? Changing that from one form to the other? Okay, but now, like I said, usually we pick x's, but picking an x here is not going to be very good for us, because then we're going to have to go and do the thing that we did there, going, 2 to the what power gives us 5 or whatever, right? And so we'd have to do, a lot of like guess and check. So we don't want to go that way. So on this, you're going to actually pick y's. So let's write that down here, because the big change, instead of picking x's, you're going to pick y's and solve for your x's. Okay, so you've got to pick some y's here. And maybe you want to start off with numbers, like that are kind of close around 0. So maybe we'll say -1, 0, and 1. And we can see what our graph looks like when we put those in. And maybe we'll need to go in and put in some more points to see what it looks like. Okay. So let's see what happens here. So when we're graphing this, grid here, okay, and so if I put -1 into this equation here, right, saying 2 to the -1 power, right, means it's going to flip it, so that's going to be 1/2. Right, so I've got the point 1/2 comma -1. Now let's put 0 in there. 2 to the 0 power, anything to the 0 power is 1, so now we have the point 1 comma 0. And then let's put 1 in there also in place of x, so 2 to the first power, in place of y. I was used to saying that, right? And then that gives us 2. So 2 comma 1 would be another point. All right, questions on how I came up with these 3 points? Is that making sense, what I'm doing? Now let's just go ahead and put some of these in here. All right, so if I go, 1/2 comma -1, so let's go positive 1/2 down 1 would be about here. Oops, let me do like a different color. Right there. And then 1, 0, so over 1 up 0 is about there. And then 2, 1, so over 2 up 1. So I can kind of see what this is looking like, but maybe I want to try a couple more y's. Maybe I want to know what's happening here when I go up to 2 and when I go down to -2. So let's do a couple more here. All right, so with my y's, if I pick my y's, another one is -2 and another one is +2. All right, so if I put -2 in place of y there, I've got 2 to the -2 power. All right, that -2 makes it flip. And then we raise that to the second power, so that will give us 1/4. And then if I put 2 in place of y instead, I've got 2 to the second power, which gives me 4. All right, so 2 more points I have. So 1/4, -2, and then 4, 2. So 1/4, -2, looks like it's going to be about here. And then 4/2 over 4 up 2 is about there. So that's a little bit better to see what's happening. So this time, look at how this graph is getting really, really close to our y-axis this time. All right, and then it's going up and out this way. Okay, so this is getting close to the y-axis, where remember with our exponentials, those exponentials were getting close to the x-axis. Right? So these are just kind of flipped. Look at the, kind of the similarities and maybe some of the differences on there. Right? If we had the exponential growth, looks like this, right? And then here is our logarithmic growth. Right? Something like this. And so you can kind of see, that it's kind of similar. You have, if I kind of put it here, it's kind of going like this, and then over like that, right? So this in pink is the log growth. Right? But they're similar to each other. They're actually called inverses of each other. Right? Because I drew a line right here. This is the line y equals x. And if I was, if this was like a piece of paper and I folded it on that dotted line, my exponential curve would land exactly on that logarithmic curve. Okay, and again, it's because those are inverses of each other. Remember we said, whenever there's a way to do something in math, there's always a way to undo it. Well, these functions are inverses of each other. Okay, so again, remember when you're asked to graph a log graph, change it to exponential form first, and then make sure that you're picking y's, right? You're picking the y's, and then solving those for x. Okay, what questions can I answer about this one? How to graph these log graphs. Nothing? You feel like you got it? Okay, why don't you try this next one then? Let's do another graphing one. Example 7. Let's graph y equals log base 1/3, right? So our base this time is a fraction of x. Okay, so what's the first thing we're going to want to do?
Change it to exponential form.
Yeah. Okay, will you help me change that to exponential form? What would that look like?
It would be,
It's okay.
got this.
Yep.
So it would be 1/2.
Or 1/3. Yep.
Oh yeah, 1/3. Y equals x.
Yeah. So 1/3 to the y power equals x. Right? Change to exponential form. Awesome. Okay, then what do we do once it's in exponential form? What are we going to pick?
Pick some y values and plug them in.
Yeah. All right, so we're going to pick the y values and solve for x. Okay. So let's pick some y values. Again, we want to keep these kind of close to 0. It'll just make it easier for our graph so our graph isn't going out so far. So I definitely want to make sure that I pick 0 as one of my numbers, but then maybe I'll also pick, you know, the ones around it. So let's do the kind of the same ones we picked up there. Let's do -2, -1, 0, 1, and 2. Okay, I want you guys to try it on this one. See if you can figure out what those x values are if we pick these to be our y's. Give you a minute to try it. What did I do there? I made a mistake when I wrote this down. All right, so these are what I came up with. I accidentally swapped my x and y when I first wrote down that ordered pair. So I'll just be careful and make sure you don't make that same mistake that I did. But it should be 9, -2. All right, so I'm going to go over 9 and then down 2 would be about here. Okay. And then 3, negative 1, so over 3, down 1, it's to be about here. And then 1 over 1 up 0 is about there. Oops, I have to do this in different colors. It's just harder to see sometimes. Okay, and then I've got 1/3, 1, so over 1/3 up 1, so it'll be about there. And then over 1/9 up 2 is maybe just getting closer and closer to that, right? So this time it's gonna get really close this way, right, going up. But then it has more of like a negative slope to it, right? It's going down and out forever like that. Okay. Okay. Raise your hand if you were able to get something like that. Let me see. Raise a hand so I can see how you guys are doing. Hey, did anybody get stuck on some of these things, like figuring out what the x value was? Right, because remember, we're using those negative exponents, and so those negative exponents mean that you need to flip it, right? So even if I like take that first one there, if we kind of rework it over here, so we're saying 1/3 to the negative 2 power, right, means we're going to flip what's inside, right? So I've got 3 over 1. But now, since I flipped what was inside, it's now raised to the 2nd power. And then I can give everybody inside that power of 2. So 3 squared is 9, and 1 squared is 1, so we don't need to do anything else with that. Right? So that's how we get that 9 for that x. Right? And then on your homework, I want to make sure that you know that when you're graphing these logs or exponentials, you've got to make sure that you're choosing ones that are whole numbers. So like I couldn't use this 1/3 comma 1, right, or this 1/9 comma 2. I'd have to pick like maybe the 9 comma negative 2 and the 3 comma negative 1. So if I just chose those 2 points and then clicked on the little, log graph that it has down there, then it will make the rest of it for you there. But you can't pick ones with those fractions because they're just only moving by whole number increments on there. Okay, but when we draw it out ourselves, we can put those in there. But not when it's on that stuff online, right? With our homework stuff. All right, I really can't tell where you guys are at on this. Some of you raised your hand, some of you didn't, but then you didn't have any questions for me, so I don't know how to help you unless you ask me the questions you're having. And just remember, somebody else has that same question you have, so please don't feel bad like asking. You're going to help so many people out. All right, let's do one more graphing one. Let's do example 7, or no, example 8. Let me select that. Okay. So example 8. This time we're going to graph. This one looks a little bit different, but don't let the look of it freak you out any. We're still going to do the same kind of thing. So y equals log base 2, and then in parentheses next to that, I have an x plus 3. Okay, so again, we're going to change it to exponential form. Right, and then after that, we're going to pick y's, pick our y values, and solve for x. Okay, So when I change this to exponential form, remember I'm doing the base raised to this power equals all of that, right? Everything there that's inside the parentheses. So that'll look like this. So 2 to the y power equals, weird, 2 to the y power equals x plus 3. Okay? And I guess there's one more thing that we have to do, because right now we don't have x by itself. So maybe we need to put a little thing in here just to make sure it's clear that you're going to solve for x. All right, so there's kind of another little step we have to do. If x is not by itself, like it was in the last two examples, then we need to solve for it. So let's subtract that 3 over. All right, so now we'll have 2 to the y power, and then minus 3 equals x. Okay, so this is what I want to use this time. All right, so I've got, put it over here, so x equals 2 to the y power minus 3. But we're still going to pick y's to figure out what our x's are. Okay, so the y's I'm going to pick this time. All right. Again, like I'm kind of looking at this going, well, I want to have something maybe that's still kind of close to 0 on this, so we could still try and pick those same ones that we have been picking. But sometimes when you plot them in there, you're like, oh, I can't really tell what it looks like, so maybe you want to, choose a few more. But let's try this. So if I picked negative 2, negative 1, 0, 1, and 2, all right, for some of my points here. Those are my y values. Now I need to figure out what my x values are by putting that in here. Right? So if I have, so I'm saying on this, I'm doing 2 to the negative 2 power, because that's what my y is, and then I'm going to subtract off 3. Right? So 2, maybe I'll do a little bit of side work over here. So 2 to the negative 2 power minus 3. Well, remember that when we have a negative exponent, we got to flip it. So that's really going to be 1/4 minus 3. Right? And 1/4 minus 3 is negative 2 3/4. Or you could do that on your calculator, right? And it would give you negative 2.75. Right? I'm fine if you, change them to decimals, or if you have them as fractions. I don't care which way it is. Okay? But that's going to give us this, let's see if I can put it here, negative 2.75. Right? So my first point that I found is negative 2.75, comma, negative 2. All right, and then I need to do the same thing for these other ones. All right. So go ahead and try those other ones. All right, so I kind of did some side work over here to help you see how I came up with these numbers. All right, so I put my y values in and then solved them for x. But I did that work over here because it just wasn't enough room over here to try and show what I did. All right, so let's put these in and see what we have. So negative 2.75 comma negative 2. So over, so 1, 2, 3. So not quite to negative 3, right? But then down 2 should be maybe about there. Oopsie. All right, then let's do the next one. Negative 2.5 comma negative 1. So over 2.5. And down 1 is maybe about there. Over negative 2, 0 is about there. Over negative 1, up 1. And over 1, up 2. So this time, this is getting, so as we're going further and further to the left, it is getting close to a line, but the line this time isn't one of our axes. It's actually this line right here, right? This negative 3. So this graph is getting really, really close to that line, x equals negative 3, and then it's going up and out from there. So this one would look something like that. Okay. Questions on this? You guys are so cool.
Would you be able to solve it the same way if you left the 3 on the x side?
If we left it here and then you just put that in, yeah, you could still do that. But it might, I mean, yeah, so if we had, so she's just asking, so if we had 2 to the y power equals x plus 3, right, you're still putting stuff in place of y. So let's say that we did this one, the y equals 0. Well, 2 to the 0 power, right, is this. And then that's 1 equals x plus 3. And then to get x by itself, we have to subtract the 3 over. So we still end up with x equals negative 2, right? So we still get this point. So yeah, you don't have to move that over to start off with, but in some cases it'll just be easier to have that x by itself to start off with, but you definitely could do that. Same thing here.
Okay, so it's basically just saving yourself a step later.
Yeah. Yeah.
Okay.
Yeah. For each question, or right, each point that you're trying to do. There, it'll save a step on each of those. Other questions? That's good. Glad you were thinking about that. Like, could you do that? Is it the same? Sure is. All right, well, let's take a little 5-minute break then, and then we'll come back and we'll talk about 6.4. Right? And if you have some questions you want to ask me about during the break, that's fine too. Or if you just want to unmute yourself and talk to each other, that is awesome. Okay, so I want to make sure that you know where you should have located your exponent button before, because when we were talking about exponents, you needed to use that quite a bit, but these are what some of them look like on some calculators. Okay, and so you got to make sure you know how to use those. But then there's also some kind of the log buttons on your calculators can sometimes look a little bit different too. So some of them might just say log, and then some of them might show log base 10, or some might just say the log of x. But anyway, make sure that you can locate those on your calculator right now, because we're going to be talking about these and using these, right? So let's first look at some exponents. You should be familiar with these. And so if I asked you to figure out what is 10 to the third power, what is that?
1,000.
Yeah, that's 1,000. Okay. And then if I said find 10 to the second power, well, that's a 1 with 2 zeros behind it. All right, so 100. 10 to the first power is just 10. 10 to the 0 power is 1, right? So there's a 1 0 that is decreasing by every time here, right? As our exponent is also decreasing. And then if we have negative exponents here, right, this is going to be 1/10. If we write it as a decimal, it's 0.1. And then 10 to the negative 2 power would be 1/100th, or 0.01, okay, and so on. So these are kind of, we've seen some patterns with these and what's happening there, okay, but now I want you to use your log button and kind of see what happens here. So I want you to find the log of 1,000, to find the log of 100, find the log of 0, and then I want you to find the log of -1. Okay, so I want you to tell me what you come out with here. Okay, so when you find the log of 1,000, so in your calculators, you'll either put in the log button, then type in 1,000. In other calculators, you'll have to type in 1,000 and then press the log button. Some of them you might have to put parentheses around them, right? It has, like, if it starts off with a parenthesis in it. Okay, but what do you get? What is the log of 1,000? Anybody?
Is it 3?
Yeah, it's 3, right? And why does 3 make sense with what we know over here?
It's like the reverse of the exponent almost. It's, 10 to the power of 3 is 1,000, and the log of 1,000 is 3.
Yeah, exactly. They're just undoing each other, right? And remember, when we're finding the log of a number, we're finding the exponent, right? That's being raised to. So that's where that 3 is coming from. All right, so then what would log of 100 be?
Two.
Yep, that one's 2. Log of 0? What happened?
0 and -1 on my calculator, it says domain error.
Yes. Okay, why does it say domain error? Well, let's look at the graph. Okay, let's look at the graph of the logs and see what we can see here, right? So if I'm looking at something kind of like this, log base 2 of x, right? Is this graph, right, is this pink graph ever going to cross that y-axis? Right? Remember we said it's getting really, really close to the y-axis, but it's never going to cross it. So that means we can't find the log, right, of 0 because it doesn't exist. It's never going to hit. There's no graph down here. If we try and find the log of -1, well, the graph doesn't exist here. Right? Find the log of -2. That doesn't exist. Right? So you can't find the log of 0 or negative numbers. Okay, so I want to make sure that that's clear. Okay, so if you come up with something like this on your homework, you would just put DNE. It doesn't exist. And you can kind of see with the graph why that doesn't exist. Right? Why you can't do that. Okay? But what if I asked you to find, let's do one more here. What if we said find the log of 0.00001?
-4.
Okay, is it -4?
Oh, I forgot a 0.
So it's going to be -5, right? That you came up with, and you can kind of see that if we were moving this back to like in front of the 1, that's moving 5 places there. So kind of like what we talked about with scientific notation and stuff, you can see kind of come into play here too. Because remember, this is talking about the exponent, right? So 10 to the -5th power is this number. Okay. Another thing that I want to make sure is clear, so these are called common logs. So on your calculator, where, you know, you just see these log buttons, and I'm going to put in parentheses here because next time we're going to talk about natural logs, but today we're talking about common logs. And so common logs always have a base of 10. Okay, let's write that down somewhere. So common logs have a base of 10. And notice that they didn't show this base here, right? So it's kind of like one of those, it's like an invisible number there. So if they don't show what base it is, we're assuming it is base 10. Okay? If they don't give it, then it's base 10. So then you can see maybe a little bit, you know, better on some of these when we're saying, you know, 10 to the 2nd power equals 100. But sometimes it gets confusing because you're like, what is that base there? It's not giving me a base, right? So write down somewhere in your notes, if that base is missing, it's a 10. Right? It always has that base of 10. And so that's what most calculators have. And why base 10? Well, because that's what, you know, that's what base we normally work in, unless you're going to be doing stuff like with computer science or, you know, some other math classes where you talk about different bases. Right? But for the most part, we work in base 10. Okay, so that's just a little bit about these buttons and what we're going to do. So now let's look at a few things, and I want you to, on all of these, I'm going to want you to round your answers to 4 place values, okay? So let's do, I'm going to say use calculator to approximate, oops, let's spell it right, approximate, okay, to 4 decimal places. That's just usually what they do with logs, is they usually go out to 4 decimal places. But make sure you watch on your homework because it could tell you to round to different, you know, a different place value. Okay, but on these, that's what we'll do. All right, so for example 1 on this 6 point, put that up there, this is 6.4. I don't know if I put that back up here. Nope. Make Make sure everybody knows we're starting on 6.4 now. We're talking about common logs. All right, so for this first example, I want you to figure out what is the log of 93. All right. I'm going to put a few of them up here. Try and find this to 4 decimal places. Then find the log like I said, in some calculators you'll have to put these parentheses in so you know what you're finding the log of. Okay, so for example 1, let's use the chat box so I can see, who's with me on this? Who's got this, right? Your calculator's doing all the work. You just got to write it down, 4 decimal places, right? So write down your answer for number 1 in the chat box. Don't hit enter quite yet. All right, so round to 4 decimal places. All right, 3, 2, 1, hit enter. All right, and we want to round that. So Jordan kind of showed us in the chat more numbers than 4 place values, but you can see kind of from that it said 4, 8 after that, and so that 8 rounded the 4 up to a 5, right? So this would be the answer that you would want. Okay, and to make more sense of this, right, remember that we said this is base 10. So this is saying 10 to the 1.9685 power is going to give us a number close to 93. Right? So I want you to try that in your calculator. Figure out what is 10 to the 1.9685 power. So it's not exactly 93, right? But it's approximately that. So when I put that in, I get 93.00365, blah, 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 right? But it's pretty close to 93, right? So remember that these are approximate, right? So really we should have like a little squiggly line saying it's approximated there, but it's telling us also here because we're only taking it out 4 decimal places. All right, let's try this one. Okay, so put that into your calculator, and figure out what you come up with there. And if you're not getting these, like if you didn't come up with that, then ask me, because I can help you figure out your calculator, what you need to do. Okay, so put this next answer in. And this time you should be coming up with a negative number. Right, and I know it's going to be a negative number because look at the number that I have here. This number that I'm finding the log of is a really small number. It's a number that is smaller than 1. So that means it's a fraction, which means it's going to be a negative exponent. Right. Okay, so hopefully you have that in there. So 3, 2, 1, hit enter. Let's see what you guys have. Okay, awesome. So negative 2.6003. That's what you guys came up with. Okay, and if you're not getting that on your calculator, let me know. All right, it's not just gonna, you're not just gonna figure it out. You gotta ask if you're not sure how to put that in, but you can play around with a few different ways that I was telling you about it. Okay, and then what about for the log of 500? Already try that. Okay, remember we're thinking Trying to figure out 10 to the what power gives me something close to 500. Trying to find that power. Okay, and on this one you should have gotten 2.69897, right? But how do I write, or how do I round this? Right, so if I want to 4 decimal places here, right, look at what's happening. This is the one that I'm trying to round to, but 7 rounds this up, right, to a 10, which rounds that up to a 9. So we'd really have 2.699, and then put that 0 behind it. All right, so there's 4 places after the decimal. Right. Because it's going to be kind of picky on your homework. When it says round to 4 place values, make sure that you're doing that and put that missing 0 in at the end there.